The lesson outcome for this video is, I can factor out the GCF, the greatest common factor. Remember that when looking for a GCF, you need to pay attention to two things. First, the coefficients of each term, and number two, the variable or variables of each term. Let's take a look at the example 3x squared plus 9x. If we're looking for the GCF of these two terms, we need to look at, well, both terms, and we have to look at both parts of each term. Again, the coefficient, which is the number in front of the variable, so 3 and positive 9. And we have to look at the variable part, which is x squared for the first term and x for the second term. So a couple of questions. What factor do 3 and 9 have in common? You won't have to do this every time, but sometimes I like to show, especially at the beginning. The factors of 3 are 1 and 3. The factors of 9 are 1, 3, and 9. There's no other numbers that you can divide 3 or 9 by. So obviously the greatest of these factors is 3. So what factor do they have in common? 3. The second question is, what factor do x squared and x have in common? Well, if you think about x is the same thing as x times x, and x is obviously just x, the greatest common factor is we've got an x that's common. We don't have another x in common because there's not another x here. So we have an x that is common between those two. So this means that our GCF is, for this problem, 3x. Okay, so we're going to write the GCF, 3x, over here, just off to the left of, down, of course, below it and off to the left. And the reason I'm going to do that every time is that I'm then going to put parentheses directly below my binomial, my two terms here. Whoops, sorry, my two terms here, 1, 2. So that I remember that each of these terms, there is going to be something remaining after I divide out the GCF. Okay, so if I have a 3 and I'm factoring out a 3, then the 3 is gone. Now you have to remember that doesn't mean 0. Instead, it's actually 1, because if we take 3 and we're factoring out, which means dividing out the 3, well, 3 divided by 3 is 1. All right, so 1. Then if we have x squared, we factored out one of those x's. Again, x squared is x times x. So if we factored one of those out, we're left with 1x here, so an x. This plus sign is always going to be brought straight into the parentheses, and I could have done that right away to remember it, but there it is. And now we have a 9, and we're factoring out a 3. So 9 divided by 3 is 3. And if we have an x and we factored it out, we don't have any x's left here. So this right here is our factored answer. We factored out the GCF. I think it's important to remember, or to remind you, that if we use the distributive property right now and distributed this 3x times the 1x and the 3x times the 3, you would arrive back at this answer right here, right? Because 3x times 1x is 3x squared, and 3x times 3 is 9x. Okay, so let's try some more examples. In each of these examples, we're going to follow 3 steps. Number 1, what is the GCF? And we'll write that down. 2, factor the GCF out of each term. And 3, write down what is left over, and we're going to write that in the parentheses. Okay, so the first one is 5x squared minus 2x. Some of you are going to want to write down the factors at least for a while to make sure that you see the common factors. If you don't feel like you need to do that, that is fine. Everybody is at a different place. So I'm going to go ahead and do so for at least the first couple of examples. My factors of my coefficients, well, 5 is 1 times 5, and 2 is 1 times 2. Now, if you think about this, the greatest common factor for our coefficients is 1, because it is the only one that's common between 1 and 5 and 1 and 2. Having a GCF of 1 doesn't really do anything. It doesn't change anything. You can't really you could factor 1 out of everything and it doesn't change it. So if you didn't want to write it down as part of the GCF, you wouldn't have to, but if you want to, we can. We also have to look at the variable part. Now x squared, remember, is x times x, and x is just an x. So is it common? Sure, there's an x that's common between those two. Not x squared, because I can't take x squared out of this term here. So I'm going to go ahead then and write my x as the other part of my GCF. So my coefficient GCF is 1 and my variable coefficient is x, so 1x is my GCF. If I write that down right here, whoops, I can just write the x if I want to, because again 1x is the same as x. Now the question is, what is left over in the parentheses? Well, if we have 5x squared and we're not factoring out the 5, we know that it stays there. So we still have a 5 left in the parentheses. But if we factor out an x out of the x squared, notice here, we'll still have an x remaining. So we'll have 5x. Then, factoring out a 1, again, doesn't change anything. We're still going to have a 2. Notice I have the minus sign right here already in my parentheses. We're going to have a subtraction sign there just like we had it here. We have a 2. And then if we have an x but we're factoring out that x, we won't have an x left here. Now, notice that if we distributed the x back into the parentheses like this, we can check to make sure we have it factored correctly. What's x times 5x? Well, 5x squared, which is what we have right here, minus, which we have. If we multiplied x times 2, that's 2x, so we'd have the 2x after the subtraction sign. The next example, number 2, is our first experience factoring a GCF out of a trinomial situation. So, first thing we're going to do is look for a numerical GCF. So 6 has factors of 1, 2, 3, and 6. 2 has factors of 1 and 2. And over here, there's a 1. So the factors of 1 are 1. What's the greatest common factor? And think back to the previous lesson on the greatest common friend with Beyonce. Okay, what shows up in every single one of these groups? The only thing that shows up in all 3 is the number 1. So again, we don't have a numerical GCF other than 1 in this example. All right, let's take a look next at our variables. B to the 4th is b times b times b times b, and b to the 3rd is b times b times b, and b squared is b times b. All right, so what is common here? Well, I do have a b in every term. I actually have another b in every term. Do I have another b in every term? No, I don't, because I don't have any more b's here. So how many was I able to circle? 2 of them, which is not 2b, but b times b, which is b squared. So 1b squared is our GCF. Again, if we want to just write b squared right here, that's fine. We don't need the 1. And now we are going to find out what's left in our parentheses. Notice I started with a trinomial. I need to end with a trinomial in the parentheses. 3 terms. Okay, so if I factor out of 6b to the 4th, I'm just factoring out b squared. I still have a 6 left. And then I had b to the 4th and I took b squared out. So I've got 2 b's left. So that's b squared. So 6b squared. That's a 6 and a b. All right, so 6b squared. In our next term, 2b to the 3rd, we didn't factor out the 2, so we're going to have the 2 left. And then we had b to the 3rd, and we're going to take out b squared. So if we had 3 b's being multiplied, we took 2 of them away. We only have 1 remaining. So a b will go here. And lastly, if I have a 1b squared here, notice that is my GCF. Okay? If I factor out a b squared, well, then there's no more b's. But what is left? A 1. Okay, there will be a 1 in that last spot. Again, if I distributed this b squared into my parentheses, I would arrive back at my original problem. All right, number 3. Again, we're looking for the numerical and then the variable GCF. So 3, well, 3 has factors of 1 and 3. 24 has a lot of factors. Now 1, 2, 3, 4, 6, 8, 12, 24. But if I think ahead a little bit, I wouldn't need to list all those. There are only 2 options. It's either going to be a 1 for GCF numerically or a 3. Now since I know 3 is a factor of 24, I know that 3 is my common factor for the numerical portion. So 3. And then I have, again, x to the 4th and x to the 3rd. So if I expanded those, I'd have 4x's written here, 3x's written here. And we would know then that we could take how many of those and factor them out? Well, 3. I can take these 3 and factor them out, and these 3 and factor them out. So x to the 3rd would be part of my GCF. So 3x to the 3rd. So if 3x to the 3rd is my GCF, I can write that right there. Looking at now my first term, 3x to the 4th. Well, I factored out the 3. So 3 divided by 3 is 1 if you want to write it here. And x to the 4th, if I factor out x to the 3rd, well, I'm left with an x. Then I have 24x. Now notice the subtraction sign is right here. We'll put that in. Now 24x to the 3rd. Well, if I have 24 and I factor out a 3, we need to say, well, 3 times what number gives us 24? And the answer there is 8. 3 times 8 is 24. Then we had x to the 3rd. Notice we factored all of those out, all x to the 3rd, so we don't need any x's here. All right, why don't you go ahead and try number 4. I'll write down the answer in a few seconds and you can see how you did on that one, and we'll of course practice more in class. Okay, hopefully you arrived at the answer 7y as our GCF, and in parentheses you should have 2y plus 3. Again, you can always check this by using distributive property. 7y times 2y is 14y squared, and 7y times 3 is 21y.